This video is a review of complex number operations. We will be dealing with I. The main thing that you need to know about I is that I squared is equal to -1. Most other things work I just like a variable, like x. But I squared is -1. Watch out for it. So in problem number 1, you would do a distributive property, and that would give you 2i plus 6i squared. But then I squared is -1. So this is 6 times -1, so that makes this -6. So I'm going to put the 2i last because standard form. So there you go. This is the answer to number 1. Okay, let's look over at number 2. If I multiply these together, that's going to be positive 32, but then I will have I squared. And then I have plus this 7i. But I squared is -1, so that makes this negative 32 plus 7i. So I guess really nothing happened with the 7i, it just sits there. So this is indeed the answer to number 2. Let's take a gander at number 3. Okay, these parentheses aren't really doing anything. There's nothing in front of the parentheses, so it's really just a matter of like terms. So I've got the 2 and the 5 make 7. So I've got 7 plus 8i. That's the end of number 3. Looking at number 4. These are really like terms. Again, the parentheses aren't really doing anything. I have -7i and I have -2i. Together they make -9i. So that's going to be the answer number 4. Alright, what about number 5? Okay, we have some multiplication about to happen. Double distributive property. So 8 times 3 and 8 times -5i. So that's going to give us 24 minus 40i. And then we're going to do -8 times 3 and -8 times -5i. That's going to give us -24i and positive 40i squared. Remember that I squared is -1. So because I squared is -1, that's going to make this into a -40 with no I. So now I can go ahead and combine my like terms. So I have 24 minus 40. So that's going to be -16. And then -40i and -24i make -64i. So that's going to be the answer to number 5. Okay, number 6. 2 times 5 is 10. 2 times 4i is 8i. -I times 5, so that's -5i. -I times 4i is going to be -4i squared. Remember that I squared is -1. So that's going to turn this into a positive 4. So that's going to give us 14, because 10 and 4, and then 8i minus 5i, so that's plus 3i. So that's the answer to number 6. Number 7. So -6 times -2, so that's 12. -6 times -i, that's positive 6i. 8i times -2, that's -16i. 8i times I, that's -8i squared. Remember that I squared is -1. So that's going to change this -8 into a positive 8. So I have 12 plus 8, so that's 20. And then 6i minus 16i is -10i. So that'll be the answer to number 7. Okay, for number 8, first I have negative 2 times 5i, so that's negative 10i. Okay, I need to do a little distributive property right here. So that's going to be positive 64. And then negative 48i. Now it's time to combine like terms. Well, 64 doesn't have a like term, so that's just going to be 64. But negative 10i and negative 48i, that's negative 58i. So that is going to be the answer to number 8. Okay, when you're dividing, you cannot have I in the denominator. And the way we get rid of I in the denominator, if you have a binomial, you multiply by the conjugate. The conjugate here will be negative 6 minus 2i. So I just changed the sign of the imaginary part only. I have to multiply the numerator by the same exact thing. So negative 6 minus 2i. So I'm going to have to double distribute in the numerator and the denominator. So in the numerator, I'm going to have, let's see, that's positive 54, and then negative 9 times negative 2i, so that's positive 18i. Negative 2i times negative 6, so that is positive 12i. Negative 2i times negative 2i is positive 4i squared. Now in the denominator, negative 6 times negative 6 is positive 36. Negative 6 times negative 2i is positive 12i. 2i times negative 6 is negative 12i. And 2i times negative 2i is negative 4i squared. Now it's time to remember that I squared is negative 1. So that's going to change this positive 4 into a negative 4. Similarly down here, again, I squared is negative 1. That's going to change this negative 4 into a positive 4. So combining like terms, I have 54 minus 4, so that is 50. 18i plus 12i, that's 30i. Alright, in the denominator, these are going to cancel each other out, and I just have 36 plus 4, so that is 40. Now, we need to look and see, is there a number that will divide into all three of these? And there is. They are all divisible by 10. So if there is a number that will divide evenly into all three, you need to do that. So dividing all of these by 10, I'm going to get 5 plus 3i over 4. So this will be the final answer for number 9. So number 10, again, we need to multiply by the conjugate of the denominator. So this will be negative 7 minus 4i, and I will do that in the numerator as well. So let's see what we get. So let's see, negative 6 times negative 7, so that's 42. Negative 6 times negative 4i, so that's positive 24i. 5i times negative 7, so that's negative 35i. 5i times negative 4i, so that's negative 20i squared. Denominator. Negative 7 times negative 7 is positive 49. Negative 7 times negative 4i is positive 28i. 4i times negative 7 is negative 28i. And 4i times negative 4i is negative 16i squared. Remember that I squared is negative 1. So that's going to have the effect of changing this over to a positive 20. This I squared also is negative 1, so that's going to make this into a positive 16. The 28i and the negative 28i will cancel out. So let's see what we've got now as we combine like terms and such. 42 plus 20, so that'll be 62. 24i minus 35i, so that's going to be negative 11i. And then in the denominator, 49 plus 16 is 65. There's nothing that will divide into all three of these, so this will be the final answer for number 10. In number 11, since the denominator is just a monomial, all I really need to do is multiply by I. I don't need to do like a conjugate or anything like that. I'm just going to simply multiply by I. So in the denominator, that's going to give me negative 4i squared. And here I have to distribute, so that will give me 5i plus 6i squared. Now I squared is negative 1. So that's going to turn this into a positive 4. And this I squared is also negative 1, which is going to turn this into a negative 6. So that's why what I really have is negative 6 plus 5i, the imaginary part goes last, over positive 4. So this is the final answer for number 11. Now, number 12, we do have a binomial in the denominator, so I need to multiply by the conjugate. 4 minus 6i is the conjugate. 4 minus 6i. In the numerator, I'm just doing a distributive property here. Boom, boom. So that'll be 24 minus 36i. In the denominator, 4 times 4 is 16. 4 times negative 6i is negative 24i. 6i times 4 is positive 24i. And 6i times negative 6i is negative 36i squared. Now I squared is negative 1. So that's going to turn this into a positive 36. Also, the positive 24i and the negative 24i will cancel each other out. So that's going to leave me with 24 minus 36i. Now 16 plus 36, that's 52. So I'm going to have this. Now I look to see, is there anything that will divide evenly into all three of these numbers? Well, all three of these numbers are divisible by 4, so I need to make that happen. If I divide these all by 4, I'm going to get 6 minus 9i over 13. So this will be the final answer for number 12. Number 13, again we must multiply by the conjugate of the denominator. So 3 plus 3i is the conjugate. We will do the same in the numerator, 3 plus 3i. So in the numerator, it's just going to be a distributive type situation. So we will have 6i plus 6i squared. Interesting. And then in the denominator, I've got 3 times 3 is 9. 3 times 3i is 9i. Negative 3i times 3 is negative 9i. And then negative 3i times positive 3i is negative 9i squared. That's a lot of 9s. Now, we remember that I squared is negative 1. So that's going to have the result of changing this positive 6 to a negative 6. This I squared is also negative 1. That's going to make this into a positive 9. Oh, wait, one more thing. Also, the positive 9i and the negative 9i will cancel each other out. So, when all the dust clears, what we have is, we've got this negative 6, which I will now put in front. So, negative 6 plus 6i. Then down here we have 9 plus 9, so that's 18. Now, looking for something that will divide evenly into all three numbers, all three of these are divisible by 6. Alright, that is the greatest common factor. So dividing all of these by 6 will give us the final answer, which is negative 1 plus I over 3. So that's the final answer for number 13. Number 14, when you have a monomial in the denominator, all you have to do is multiply by I. So that's what I'm going to do. I'm just going to multiply by I in the numerator and the denominator. In the numerator, I have to distribute, however. So this will give me negative I minus 7I squared. And in the denominator, I have negative 2I squared. Now, remember that I squared is negative 1. So that's going to change this into a positive 7. And again, here, I squared is negative 1, which will change this into a positive 2. So what I will have once all the dust clears is, so I've got positive 7 here. So I'm going to go ahead and put that in the front. So 7 minus I, the imaginary part goes last, over positive 2. So this is the final answer for number 14. Now, in a previous video, we learned a shortcut for simplifying I to any power. And it relied on a chart, and the chart went like this. Alright, my chart has 3 columns and 4 rows. So let's reproduce. Okay, so in the first column I have I squared, I to the 3rd power, and I to the 4th power. In the second column I simplify these. I cannot be simplified further, so that's just I. I squared is negative 1. I to the 3rd power is negative I, and I to the 4th power is positive 1. So these are the only 4 possible answers. I, negative 1, negative I, and positive 1. Now, in the 3rd column, I think money. Quarters. 1 quarter is 25 cents. 2 quarters is 50 cents. 3 quarters is 75 cents. And 4 quarters is a whole dollar. After that, division. I'm going to take the exponent and I will divide by 4. For example, if I do 43 divided by 4, that is 10.75. Focus on the 0.75. That puts us here on the chart. That means the answer is negative I. So this is negative I. 82. 82 divided by 4. That's 20.5. Look at the 0.5. That puts us here. The answer is negative 1. What about 64? 64 divided by 4. That's 16. No decimals. Goes in evenly. So that puts us here. No decimals. That means the answer is 1. What about 97? 97 divided by 4. That's 24.25. Look at that 0.25. That puts us right here. The answer is I. What about 234? 58.5. Look at that 0.5. There's my 0.5. The answer is -1. What about 551? 551 divided by 4 is 137.75. Look at that 0.75. There's my 0.75. The answer is -I. So that's a shortcut for how you can simplify I to any power. Now, graphing a complex number in the complex plane, you have the real part, the imaginary part. Instead of the x-axis, we have the real axis. Instead of the y-axis, we have imaginary. So this -4 means -4 on the real axis, which is here. This -2 means -2 on the imaginary axis, which is here. So this point would be here. So left 4, down 2. That's the bottom line. So on this one, this would be right 2, up 4. So boom, boom. It would be here. This one would be right 3, down 5. So right 3, down 5. That's going to be right here. Okay, this is going to be right 4, down 3. So that will be right here. Okay? Now, absolute value. If I want to do the absolute value of a complex number a plus bi, that's going to be the square root of a squared plus b squared. Notice there's no I in here anywhere once we do this. Okay, so I need to just erase this. So, for number 25, that's going to be the square root of 8 squared plus 8 squared. So that's going to be the square root of 64 plus 64. Okay, so that's going to be the square root of, now I could add these numbers and get, you know, like 128, but I'm not going to do that. 64 plus 64 is the same thing as 64 times 2. I'm going to write it this way because I want to simplify this. The square root of 64 is 8. And then I will have the radical 2. The 2 stays under the radical. So that's going to be the final answer here is going to be 8 radical 2. Okay, let's do number 26. So for number 26, I'm going to have the square root of 2 squared plus -6 squared. Alright, I'm just doing the a squared and the b squared. So that's going to be the square root of 4 plus 36. So that's the square root of 40. So that's the square root of 4 times 10. The square root of 4 is 2. So I'll have 2 radical 10. So that's going to be the answer here will be 2 radical 10. Okay. Next, number 27. So this is going to be the square root of -10 squared plus 5 squared. So that's going to be the square root of 100 plus 25. So that's the square root of 125. Well, 125 is 25 times 5. So the square root of 25 is 5. So that's why I will have 5 radical 5. So that's the answer for number 27. Alright, how about number 28? For number 28, I will have the square root of -2 squared plus -2 squared. That's going to be the square root of 4 plus 4. That's 8. also known as 4 times 2. So the square root of 4 is 2, so then I will have 2 radical 2. So that's the answer for number 28. Okay, how about number 29? For number 29, we will have the square root of negative 9 squared plus negative 2 squared. That's going to be the square root of 81 plus 4. That's the square root of 85. That does not simplify, so I will just have the square root of 85, and that's it. Okay, how about number 30? So for number 30, I will have the square root of 5 squared plus negative 3 squared. So that's going to be the square root of 25 plus 9. That's going to be the square root of 34. I don't think that simplifies, so I'm just going to have the square root of 34. Alright guys, that's going to do it for this review. I hope it was helpful, and I will see you on the next video.